All right, so today we are starting chapter 5. So we're doing the first section, section 5.1. It's all about inequalities. Do you guys know what inequalities are? Have you ever heard of this? They're very, very similar to equations. So if you liked equations, like solving 1- and 2-step equations, you're going to love this chapter. All right, so very similar to equations. In equations, we'd have like x equals 2. The only difference is now with inequalities, we're talking about things that are greater than, less than, greater than or equal to, less than or equal to. So similar to equations, but not quite. So today is just a brief introduction to these inequalities. So our goal is to just understand inequalities, and we're going to graph inequalities. So we can just talk our way through this. Doesn't need to be in your notebook or anything. The first one says that you have to be taller than 36 inches to ride a roller coaster. What does that mean to you? Like you're at Six Flags, you walk up and it's like taller than 36 inches. What does that mean? So like how tall?
4 foot.
Let's not convert to feet. Let's just stay in inches. What's an inch height that would be allowed to ride the roller coaster? 37. Good. What's another one? 38. What's another one? Good. Okay, so you guys get it, right? Who would not be allowed to ride? 36 would not be allowed. If you have to be taller than 36, 36 isn't allowed. 35 is not allowed. 34 is not allowed. You see where we're going with this, right? That's an inequality. In this inequality, if I was going to write an inequality, I would say that x, that's the number we're talking about, the number to ride a roller coaster, would have to be greater than 36. That's what that would look like in this class. Next one, you have to be 16 or older to drive a car. So who gets to drive a car? 16-year-olds and 17-year-olds and 18-year-olds and 19-year-olds. Great. What about 15-year-olds?
No.
What about 15.9?
No.
You got to be 16, okay? The way we'd write that in this class would be x. X would represent how old you have to be to drive a car. That number would have to be greater than or equal to 16. See the line underneath? That means or equal to. We'll talk more about that on the next slide. All right, and then last one. You have to be younger than 5 to play in the play place. It's like you're at McDonald's, and it's like you got to be younger than 5. Who can play? 4, 3, 2, 1, 5. So the way we'd say that is x. X would represent how old you have to be to play in the play place. Would be less than 5, not or equal to 5. Any questions? This is just the general idea of inequalities. All right, let's start putting some stuff in your notes. So there are 4 basic symbols for inequalities. These are the easy ones. These are the ones you usually learn first. This is called the less than symbol. This one is greater than. Now, we looked at some where the actual number you're talking about is part of the solution as well. That's less than or equal to. It sort of has like half an equal sign underneath. We also have this one, which is greater than or equal to. All right, later on today, we're also going to talk about how to graph these things on a number line. So I'm going to have you put some information over here that might not make a whole lot of sense right now, but we'll get there, I promise, okay? So when you're talking about less than something, you circle the number you're talking about and you draw an arrow to the left. Just put this, again, it'll make more sense when we start doing number lines, but I want you to have all the information right in one spot. Greater than is same start. You just circle the number you're talking about, but greater than numbers go to the right. Less than or equal to, you circle the number you're talking about and you fill it in to show that that number counts too. And you go to the left. Again, if you're like, I don't know what she's talking about, it'll make more sense when we put it on a number line. Greater than or equal to, you fill it in and you go to the right. So let's just go through one at a time. So this is the number that would go in for the x. Is 10 greater than 10? No. So that's not going to be one of our answers. You can cross it out if you want. Or you can just not circle it. That's fine. All right, next, see if 15 works for x. Is 15 greater than 10? Yes. So this would be one of our solutions. Is 9 greater than 10? Nope. And is negative 10 greater than 10? Nope. So the only correct solution here is part B, 15. So again, you're taking the x out, you're putting these numbers in. If it's true, circle it, it's a solution. If it's not true, you can cross it out or just leave it alone. What are your questions on this? All right, here's number 2, same idea. So I'll give you a second to write it down. We have x is less than negative 4. Possible solutions are A, 10, B, negative 6, C, negative 9, D, 0. We're going to circle all the ones that work. All right, so 10. Is 10 less than negative 4? Nope. This is where it gets a little tricky. Is negative 6 less than negative 4?
Yes.
Yeah. Remember, the farther you go down a number line, like if I drew a number line and this was 0, negative 1, negative 2, negative 3, negative 4, any number to the left of negative 4 is going to be less than it. So the farther you go into the negative, even though it looks like it's kind of getting bigger, right? It actually has a smaller value. So this is a solution. Same thing for negative 9. Is negative 9 less than negative 4? Yeah, it's farther into the negative. And what about 0? Is 0 less than negative 4? No, it has more value. A lot of times with these, I think of money if I get stuck. Like, is it better to owe someone $4 or owe someone $9? Well, you're going to have less money if you owe them $9, right? So that would be smaller than just owing them $4. You'll end up with less money. You know what I'm saying? Does that make sense? Am I saying wrong? Any questions? Which ones would be solutions to x is greater than or equal to 5? Yeah, 9's greater than 5. Good. Not B, right? What about C? Yeah, remember, or equal to works here. 5 greater than or equal to 5, yes. And then 15 works as well. So lots of solutions on this one. And remember, the line underneath the greater than is why it's also or equal to. That's why the 5 works. Questions? All right, couple more on this one. As you're writing this in your notes, can anyone read this to me? Less than or greater than. What?
I mean, x is less than or equal to 1.
Very good. X is less than or equal to 1. Does 1 work? Uh-huh, because it's or equal to. Does 5 work?
Yes.
If you put a 5 in here, the big mouth would be eating the 1 when the 5 is clearly the one it should be going to. So no. 5 is not less than or equal to 1. 9? Negative 1.
Yes.
Yep. Good.
So what does it down?
Yes. More time on this one? All right. This one we're going to read out loud. See, it says read. And we're going to graph it on a number line. So don't work ahead because there's a very specific way I'm going to let you graph these, and it's probably a little easier than you think. How would I read this? Let's read it first.
X is greater than 5.
X is greater than 5. Good. So on a number line, there's a few important things. One of the important things is arrows on both sides. I want to know that this goes on and on and on. Numbers to the left, numbers to the right. Another super important thing on a number line is the 0. I always put the 0 right in the middle. Boom. Now, you can put in as many numbers as you want or as few numbers as you want. I am only going to put in the essentials. 0 is an essential number on any number line. In this number line, I also need the number 5. And then I'm just like a balanced person. If I'm going to put 5, I also want negative 5. This is all I'm requiring on your number lines. Arrows on both sides, 0 in the middle, the number you're talking about, the opposite. So if you're talking about 5, I need a negative 5 on there as well. If you're talking about negative 10, I need a positive 10 on there as well. 0 square in the middle. All right, and we'll practice this a couple more times. Now you're showing me visually what numbers are going to make this true. So solutions start where? At the 5. Is 5 included? Is it an or equal to? No. The way we show that 5 is not included, but it's where it starts, is just to circle it and leave it blank. It's an open circle. Again, that shows we're starting at the 5, but 5's not part of it. So like 5.00001 works. 5 does not. Starts right at the 5, and then any number bigger than or greater than the 5. Now, are numbers that are bigger than 5 to the right on a number line or to the left on a number line? What's a number bigger than a 5?
6.
Where would 6 be? To the right, okay? So you're just going to color in that direction. So make it nice and bold and color in that arrow to show that all the numbers that are going off in that direction also work. So the important thing, the 0, the number you're talking about, the opposite, and then open circle, closed circle, and then which way is your arrow going. So lots happening here. If you draw a blank, though, remember, we already put this information in the beginning of the notes before you even knew what we were talking about. It's already on your paper. Any questions? All right, here's our next one. Who wants to read it? Yes, sir.
X is less than 4.
X is less than 4. So on my number line, I need 0. I need the number that I'm talking about, 4. I need the opposite. Now, some people want to go through and put like 1, 2, 3. You don't have to do that. If it makes you feel good about your graph, go for it. But it is not something that I'm requiring you to do. I want these to be very quick visualizations of the solutions. I don't want you to sit here and have to draw a bunch of little tick marks. All right, where do the solutions start? At
4.
4. Is 4 included?
Yes.
No. If 4 was included, it would have this or equal to. 4 is not included. So I want to start at the 4, but I don't want the 4 to be part of it. So just circle the 4, leave it open. That means it starts right at the 4, but 4 is not part of our solution. And then where are the smaller numbers? To the left or to the right?
Left.
To the left. Good. Now, some students, I'm not a huge fan of this, but I'll show it to you anyway. Some students like to think of the inequality symbol as like an arrow. See how there's like an arrow pointing to the left? So you're going to shade to the left. Now, I caution you though, that only works when the X is in the front. Some people like if it was 4 greater than X, that would get us all backwards. But if your variable's in the front, the arrow trick should work. Any questions? All right, here's number 7. All right, can anyone read this to me? Anyone else read this to me? Very good. This is read as X is less than or equal to -2. On the number line, I need arrows. I need a 0. I need the number that I'm talking about. It's a negative, so it should be to the left of the 0. And then I need its opposite, so to the right of the 0, a +2. All right, where's my solution going to start? -2. Is -2 part of my solution?
Yes.
Yes, because it's an or equal to. The way I show that graphically is to color in the circle. So it starts at -2, and -2 is part of it. And then less than or equal to is to the left. Starts at -2, includes -2, goes to the left. So things like -3, -4, -5, and all the other numbers down the left side of the number line. Questions? All right. I believe this is our last example. Anyone else want to give it a try? Someone who hasn't talked yet today, maybe? You want to do it? No? All right, you can go. X is greater than or equal to 6. So on my number line, I need the 0, I need the 6, I need the -6. This solution starts at 6. Does it include 6?
Mm-hmm.
It does. So I'm going to go ahead and color in that circle on the 6. That shows that 6 is a solution. 6 works. And then where are the numbers greater than 6? To the right or to the left? Right. To the right. Numbers like 7 and 8 and 9 and 10. What are your questions?